So, member of the conference, good morning. Today, I'm glad to present the bulk of my work entitled A Formal Composition of Multi-Agent System, organization based on category theory. This work was effectuated in collaboration with Dr. Souidi Mohammed Habib. So, we switch this plan. We say in an introduction, after that problem description, YAMAM modeling with category theory. After that, the composition of YAMAM and another model organization, which is named is AGR. After that, the conclusion. So a multi-agent system represents a set of agents that communicate with each other to meet a specific need, a goal, or to accomplish a task or a set of tasks. The evolution of multi-agent systems and the cooperation between agents opened the way to the emergence of the notion of organization for this type of complex systems. So, masses organizational models can be defined as mass mechanisms used in order to coordinate the agent's behavior to accomplish complex tasks. Several models have been presented in the literature that take in consideration the notion of organization, such as agent group role. Yet another multi-agent model, YAMAM. AGR organizational model can be considered as one of the most popular organizational mechanisms used in the last years. This model is based on the three different concepts, which are agent, group, and role, used simultaneously to reflect the system behavior. AGR was applied to the, for example, the pursuit evasional games in order to provide a pursuit coalition for formation, allowing the grouping of the pursuers to capture the detected evaders. So we have, in relation to AGR model, YAMAM is not based on the concept of group. However, it is based on four concepts: agent and role, tasks, and skills. The main principle of YAMAM can be resumed as follows. In order to play a specific role, an agent must have the appropriate skills in order to be able to improve the specific tasks. To study an organizational model agent system, it's necessary to model these elements and the relationship between them, as well as the relationship with the environment in which it is located. We have category theory to represent the YAMAM, the model, the organizational model. So the category theory represents a multidisciplinary mathematical toolbox. It has been used in many fields of computer science. This theory offers a rich body of theory for reasoning about structures, objects, and the relationship between objects. In relation to existing formal methods, category theory provides the ability to organize and layer abstractions, as well as to communicate between different structures. So category theory is based on composition as in algebra languages. It's at a very high level of abstraction, represented by a set of objects in the form of category, morphisms between objects that represent the relationships between them, and functors between categories. These notions will be used for modeling and composition of organizational model systems. The category theory, in its principle, as indicated by its definition, represents categories of objects and the link between objects, as well as links between these categories of objects, which can be sets of groups. This resemblance with the models of organizational model multi-agent systems, which are also groups of agents, links between agents and links between groups of the organization. The agents play rules and perform tasks. These explicit links represent a support of the choice of the category theory for the modeling of the organization masses. Here we have the representation of the AGR and YAMAM. The concept of the organization is very important in relation to multi-agent systems. The use of the organization in the fields requires a formal framework to mathematically manage it and validate and trust in masses properties. Several models have been made to reflect the importance of the organization, as we present before, in multi-agent systems, and to lead to effective solution to complex problems, such as AGR and YAMAM. The relation between AGR and YAMAM models is that they have common concepts, agents and rules, and to develop the relation between these concepts and takes the benefits like the access to rules by agents. The agents have to improve skills to take the rule and use the notion of groups to simplify the accomplishment of system tasks. We will integrate them into a new model in a formal way. This new model, which will contain the notion principles of the two models, AGR and YAMAM, and use it to resolve several complex problems. So, a categorical representation of the AGR multi-agent systems was recently introduced to the use of category theory. And secondly, category theory will allow us to represent or to transform the concept related to YAMAM in a formal model, examine them in an abstract way, and formalize the system as a collection of objects, categories, and morphisms with the aim of reasoning about these objects and their relationships or interactions, such as morphisms. Secondly, category theory will allow us, therefore, to compose them, then take into consideration the benefit of the concepts forming the composition model in only on the system categorically by using comma category. So the objective of this work is to take advantage of the non-common concepts that make up the two models in order to see the emergence of a new, more complex organizational model. So, in what follow, we present the categorical modeling of YAMAM, examine its structure and represent the YAMAM concepts, skills, tasks, role, and agents, and their relation via category theory. So the organization is represented by a set of agents who have goals, tasks, skills, and rules. The goals of which the agents works to achieve them. It performs a set of actions and plays one or more rules in order to achieve desired goals. Agents may have new goals after a system update, which case new actions to perform and rules to play. An agent communicates with each other and cooperate to achieve the overall goals of the organization. So an agent is defined as an autonomous entity in an environment equipped with sensors able to communicate and use skills to complete tasks. These skills can be evolved over time. And rules is defined as a function or form of agent identification or service. A role can be played or assigned to one or more agents in an environment. A set of tasks to be performed by agents. We consider that an agent can play a role only if he has the skills required to perform the task involved for this role. And skills is represented by a unit of knowledge necessary for the processing of given tasks. An agent can be aggregated several skills in order to perform the required set of tasks. And tasks is the operation of a skill or an action that requires one or more skills to complete it. It will be represented by 4 categories: agent category, role category, task category, and skill category. So agent category. The agent category encompasses all agents of the YAMAM organizational model represented by the objects, which can be autonomous objects in an environment capable of communicating and using skills to complete tasks. Morphisms are the identity morphisms of each object let's say agent. And after that, we have rule category. And in its definition, a rule is a function or a form of agent identification or a service. A role can be played or assigned to one or more agent in an environment, a set of tasks to be performed by agents. So to represent the role category, we have to identify the task category. And task category in YAMAM model, it's an operation of skills or actions that requires one or more skills to complete. So the tasks category is linked to the skills category. And agent is able to complete a given task if it has the necessary skills. The set of unit of knowledge that represent the skills. To define the task category, so we must define the skills category and go up to the role category. So this knowledge units category. And after that, the skills category represented by one or more units of knowledge necessary for the processing of given tasks. An agent can be aggregated several skills in order to perform the set of required tasks. So once we have designed the skills category, we will create the task category. As its definition indicates, tasks is the operation of skills requiring one or more skills to complete it. So here we have the objects and the morphisms to pass from the skill category creation to skill, to pass from the unit knowledge to skills category. And after that, the role category is represented by one or more sequence of tasks to be executed sequentially. And here we have the skills category to represent one or more unit of knowledge necessary for the processing of given tasks. An agent can be aggregate skills. And here we have the rule category. So here we have the agent category and the unit knowledge category to create skills after that category task and rules. And the agent can take rules if he have the skills category, the skills for this rule. After we have the categorical representation of YAMAM, we have also pass to comma category. It's a category where the basic idea is the evaluation of morphisms of a category C to objects of the category, the other categories. So we have two categories, A and B. The complete generality for this category can be obtained by taking subclasses of morphisms, those whose sources is in the image of a functor L, and whose target is the image of another functor R, B to C. So comma category that will be used to compose the two models of YAMAM and AGR. And the composition of objects and morphism in comma category is defined by a component st, comma st prime t prime, and the identities are pairs of identities. So the category comma are associated with two project functors, left functors and the right functors. We have this square has to be commute. And here we have the AGR, the following figure present the two organizational models, on the left AGR and on the right YAMAM. And we have presented the categories in the form of objects to simplify the drawing of categories of the two AGR and YAMAM systems. These two models will be composed in a new category in the middle as shown in the following figure. So the object category agent point to the object SI via L, and the object category group B point to the object G, and the category agent point to category group B, which implies a morphism between the object CA and the object G. So the source is linked as a functor L, and whose target is like another functor R in comma category. An agent can take the role if he has the skills necessary for these roles. To the functors R4, the agent points to the object skills which have the abilities to use them to play the roles and complete tasks related to them. So here we have the composition of the two models in the middle. And it is the object of this work. And finally, the modeling of organizational masses, and in this aspect, and compose two organizational masses models. And the complexity of these tasks requires a formal that has great power of expression and analysis and verification. Category theory is better placed for this purpose. It's a very sophisticated toolbox for its categorical and interpretation. The advantage affected by category theory: first, visual formalism, mathematical supports, modularity, hierarchical specification, and easy description of the system. We can consider it's the most suitable for modeling the dynamics of discrete systems, organizational aspects. Category theory as a powerful graphical theory that allows the system to be easily understood, and also allows the simulation of its activities. This formalism is well situated to the formal verification of organizational masses, which contain both states and events represented by the interaction between the different agents, as well between groups of agents and the rules in the organization. So the category theory allows us to switch to several non-modeling modes, such as graph of sets. This is very important. Links represented by a functor f allows us to switch between the mathematical representation, which gives us the possibility to reformulate the situated problem via groups, sets, topos. And this allows us to use the characteristics and properties of each domain to solve the starring problems. The use of category theory is in the composition of systems in general, and more specifically multi-agent organizational systems, as a new way of modeling them, open the way perhaps to solving very complex problems in the future by mastering the mathematical tools it's offer. And thank you for it's the first time I present in English, so my first language is French. So it's for that I thank you for your attention.